So we've done distance time and velocity time graphs with straight lines. Now we want to look at distance time and velocity time graphs with curves instead. And this is very much about estimating and finding averages. The distance time graph. Here's a distance time graph. It tells us that we start off, we're accelerating, the velocity is increasing until we reach 20. When we've got this far away, we stop. Then we start speeding up, going away again. We reach our destination, presumably, and then we come back again. Yeah, we can tell how quickly we're going away because of the steepness of the curves. We can see that just here, the distance is 20 and carries on being 20 from 1 to 1.5. Let's find the average speed in the first hour. For the average speed, equals distance over time. That equals the distance we've gone is 20 kilometers. Time is 1 hour. 20 kilometers per hour. And it is as easy as that. The average speed in the first hour is 20 kilometers per hour. Estimate the speed at 1 hour, 45 minutes. That's slightly different. Now, 1 hour, 45, so that's just here. Now, speed is part of a curve. And we can't quite tell, looking at it, what the gradient is. So now I'm going to break the habit of a lifetime and actually use a ruler to draw a straight line. Firstly, I need to show the marker that I knew where 1 hour 45 was. So there's 1 hour 45. Each one of these squares is actually 1 centimetre wide, I think, yes. So there's the middle. I want to go straight up there. Dotted line. It just tells the marker, look, that's where 1 hour 45 is. Please give me a mark. Now I need to work out what the slope is here. The slope is only going to be an estimate. What I'm going to do is put my ruler alongside the line. And I can see that just here, there's a whole bunch of lines I could draw that are approximately the same as the slope of the line. But I think that's about best. Move my ruler back a bit so I can fit my pen in there. And I'm going to do this line, which is my estimate of the slope, that point there. It's only an estimate. The marker is not going to expect an exact answer from me. He's going to expect me to take a line that's approximately touching and tangential to the curve. It has the same slope just here as the curve has just here. Let's work out what that slope is. The speed equals distance over time. So do we have a nice simple distance and time we can look at here? That looks to me like that's very close to 1 hour, 1.5 hours. Let's take a look at that. And this one here is a nice bit. Take this bit of the curve. I can take the distance there, which is 30. So I should say approximately, actually. Tell the marker I know it's not exact. 30 over that time there. Well, we know that each square is 1 centimetre. So I've gone 1, 2, 2.3 approximately. So that's 1 hour. And that's 0.3. 1.5. So 30 over 1.15, which equals 30 divided by 1.15 equals 600 over 23. That doesn't look very useful. 26.1. Let's just put the full actually. 26.086 ... This is an estimate. They are not going to want me to estimate this to 3 decimal places. So speed is approximately, well, they will not want it more than 26, will they? 26 kilometers per hour. Okay, let's look at this second one. Estimate the acceleration at 1 hour. So again, we have at 1 hour. Don't think I need to put a line on this time. Just want to say where 1 hour is, but I do need to use a ruler again to indicate to the marker I know what I'm doing. And I want to draw a line that's roughly the same gradient as the line, so as the curve at 1 hour. And it looks close. So estimate the acceleration at 1 hour. There's my slope. I'm going downwards. I'm going down by, we take this as being 41, I guess. Acceleration is approximately, so it goes down by 41 over a time of 2. That's 2.5, so 2.3. Which equals, again, negative 41 over 2.3. I don't think they want me to work that out in my head. Negative 70.826 ... Acceleration is approximately minus, I think, 2 significant figures, 18 kilometers per hour per hour. Acceleration is approximately minus 18 kilometers per hour squared. Second part there, estimate the distance traveled. Now the distance traveled, we've got some nice bits. We've got this bit here, which is a rectangle. I can do that bit without any great trouble. Got this bit here, which is also a rectangle. I can do that bit. Then we've got these two bits. Let's start, we've got an end. To estimate that one, I think I can draw a trapezium. So estimate using trapezia. Oh my God, 0 to half the time, 0 to a half, area equals a half times 15 time half to 1.5. What is 3 over 2? Area equals approximately. Estimating as a trapezium, we have half A plus B, 30 plus 10 times 1. That equals half times 40, 20. And we've got time, 3/2 to 5/2. Area equals 1 times 10 equals 10. And then we've got time, 5/2 to 3. Area is approximately a half. Base 10 plus 30 times width is half equals 40 divided by 4 equals 10. Distance is approximately 15 plus 20 plus 10 plus 10, which equals 20, 30, 40, 55, and the units are kilometres. We know that number's wrong. We know it isn't actually 55 kilometres. It's a reasonable estimate. 55 kilometres by breaking it down into rectangle, rectangle, trapezium, trapezium.